Hi, this is Ken Johnson for another episode of SecCast. This tutorial is part of our Ruby on Rails secure coding series centered around OWASP's top 10 list. Today's tutorial will cover security misconfiguration in Rails applications. This topic encompasses many insecure defaults, and we've broken this down into several pieces to focus on. Firstly, we'll cover how to detect outdated software. Next, we'll move on to common environment configuration flaws. Thirdly, we'll introduce you to secure headers if you aren't familiar. And we'll wrap up with showing you one way to keep yourself safe when developing a Rails application locally on your machine. Let's get started. In order to detect insecure and outdated libraries, two tools come to mind for Ruby on Rails: Bundler Audit and Gem Canary. Bundler Audit is a Ruby gem and command line tool that allows you to easily detect outdated libraries, and it provides references as well as alternative versions that you can use. To install, we'll type gem install bundler audit. Once this has installed, we'll type bundle audit in order to audit our gem file. You can see that as of right now, it hasn't detected any insecure libraries, annotated by no unpatched versions found. Let's open up that gemfile.lock with our text editor. The gemfile.lock is the actual file that Bundler Audit checks in order to determine what versions of Ruby gems we are using. We'll do a search and replace and change 3.2.19, the latest minor release, in the Rails 3.2 major edition, and replace it with an outdated version of 3.2.11. This should cause some notifications by Bundler Audit. Next, let's type bundle audit and review the result. As you can see, we now have warnings with the vulnerability that each gem presents, alternative versions, and their corresponding OSVDB identification numbers. I'd highly recommend integrating this as part of your continuous integration toolset. Next, we have the site called Gem Canary. This tool accomplishes the same goal but also notifies you when a vulnerable gem has been added. A huge plus with minimal setup. We'll sign up via GitHub, remove the authorization which allows the site to see private repos in favor of only public repos, and start monitoring. Let's review the repository. You can see that we have a check mark next to all gems indicating we do not have any vulnerable versions, which should be the case. Note that you can leverage this tool to review all of your gem versions in a nice interface. Again, if there are vulnerable gem versions in use, this site would notify us of such. The following is our application configuration file. The first thing we'll notice is that our escape HTML entities JSON method is set to false. Firstly, this should always be set to true. This will prevent dynamic content such as user-supplied content from being unsafely rendered in the raw versus safely escaping malicious characters. This is a prevention technique for cross-site scripting vulnerabilities. Next, it should be noted that in Rails 3.2, the default active support config declaration must be changed as it does not work. Instead, call active support directly as demonstrated. Lastly, with the exception of Rails 4, you want to ensure that whitelist attributes are set to true. This option requires your models to leverage whitelist attributes in order to prevent mass assignment vulnerabilities. Although the case can be made that accessible attribute declarations are additional overhead, this overhead is well worth the effort considering the potential impact even one mass assignment related vulnerability could cause. Finally, do not forget to change the default secret token value generated by Rails. This is a precaution born out of paranoia for me, but I always like to change this auto-generated value to something I've defined, given that it is used to secure user sessions. Another very simple thing you can do to enhance your default security settings is to leverage the Secure Headers gem written by Neil Matato. This library adds some instant protection against clickjacking and other attacks. To install, we'll open our gem file and type gem secure headers. Next, we'll run bundler to install. The last thing we need to do is add the ensure security headers method call in our application controller in order to activate or invoke the gem's protection. Finally, you can see a side-by-side of our response headers before using secure headers and after. On the right, you can see that secure headers added an X-frame options header and content security policy headers as well. I'd highly recommend using this gem, and although there are lots of options with more advanced configurations, an entire tutorial will be devoted to this, but as far as basic security headers go, this will do just fine. The final topic we will cover is a fairly simple one. You do not want to give folks access to your locally running development version of your application, whether it be because of the stack traces it generates or gems like better errors which allow you to enter in code and ultimately execute system commands. Imagine if you were sitting at a coffee shop working on your application. Would you really want anyone in the coffee shop to have access to your locally running copy of your site? In order to prevent this, you can start Rails with a binding option. By default, the Rails server will bind to all interfaces, allowing anyone to browse directly to port 3000 on your machine. In order to disallow this option, pass in the binding option and specify the loopback IP or 127.0.0.1. Now only you have access to your development copy. To recap, we've discussed and demonstrated detecting outdated software, unsafe environment configuration options, and the use of the secure headers gem. I'm Ken Johnson. This has been another episode of SecCast. Thanks for watching.